Everyone, you are welcome to my YouTube channel. I am Ridwan Ibrahim. In this tutorial, I will be showing you how to make a Power Foundation design using the Pilesoft Excel spreadsheet. So the Pilesoft Excel spreadsheet is just a sheet specifically made for Power Foundation, all right? So in cases whereby you may need to make comparison between your manual calculation and your software-based calculation, you can easily use the you can easily use the Pilesoft Excel sheet. So firstly, I will start from this image here. You could see that there is you would see that there is an elevation section and there is a plan section. Shaded here in blue is the column, here in gray is the pie cap, and in orange is the pie itself. So the load path of a structure comes from the top. So you could say it comes from the slab onto the beam, then onto the column, then onto the foundation, and then finally into the soil. So there is always a connection between the column and the foundation. So the pie cap and the pie, they are the foundation, but the column is part of the support structure. So it is the one that takes the load into the foundation. So while we have this pie cap, is just to take the load from the column and distribute it over some pile foundation and also onto the soil, because you would see that most of the time the pie cap sits not only on the pile but also on the soil. So that simply means the load from the pie cap is usually distributed onto the pile and onto the soil, but majorly onto the pile. All right. So you just have some parameters to fill here. You have two common types of shaft. It could be circular, it could be square, but majorly it is circular because circular has so many advantages in terms of the resistance compared to the square. So here is circular, and then you have penetration. So penetration is simply the thickness at which the pile goes into the pie cap. You know, there will be a connection between the pile and the pie cap. So the pile needs to go into the pie cap for a proper connection. So you will feel your penetration depth here, and then your pile diameter. Your pile diameter should be gotten from your soil report. For example, in this case, so this is a table made by the geotechnical engineers that did the soil report. I have about 3 diameter that has been recommended. I could use 0.3 diameter at a depth of 12 meter, and then the safe working load will be 150.95. all right, so I have 2 depths. I could either use 12 meter or I could use 14 meter. So with 12 meter, I can use either 0.3, 0.45, 0.6, and these are the corresponding safe working load. You'll see that as the diameter increases, the safe working load also increases. Or I could use a 40 meter length pile and also use any of this diameter, and this is the corresponding safe working load. So in this case, let me just use 14 meter and use a diameter of 0.45. all right, so this will be my safe working load 351. So let's get into it. I'll use a diameter of 0.45, so that will be 450, and then this will be 14,000 millimeters. all right, and then your column load, which is the load coming from the column, you could take that from, possibly if you have done your superstructure analysis with a software, you can take it from the software, and if you have done it with some type of spreadsheet like this, you just need to take the value and put it here. In this case, I will just leave it as it is, all right, but then you can change it for sure. Then the safe working load, this will also be gotten from the so that is 351, right? So 351.48, which is corresponding to the diameter and the length that I am using. all right, 351.48. I'll change this to 351.48. and then the column type, we could assume you are using a circular column, so I would say a circular column. And then your concrete type, of course, I expect it to be a normal concrete, but it could be a lightweight concrete as well. That is for your pile. So a normal weight concrete. So the spacing multiplying factor between your pile, this could be 2.5 or 3. But let's check what we have in the soil report. So if you check note 4 here, it says, sorry, note 5, it says it should also be, it must be ensured that groups are not heavily loaded, all right? And the pile spacing should not be less than 3 times the pile diameter. This says it should not be less than, so it means we need to use 3 at least, all right? So you come here and you change this 2.5 to 3, all right? So maybe I should just explain what that means. So I'll take another section. You take a section like this. So what this means is that you want to know what the distance, what the least distance between here and here should be. You know, you have a pile here, you have a pile like this. Let me take it down, right? So the spacing between this pile should not be less than 2.5, sorry, should not be less than 3.0 multiplied by the diameter of the pile. So in this case, the diameter of the pile is 450, right? So 450 multiplied by 3, that will be 1350 mm. So it means the distance here and the distance here should not be less than this figure, which is 1350 mm. So this is the specification. It could be 1400, it could be 1500, it could be anything, but it should not be less than 1350. All right, so let's see that. So you will see that what I have here is 1500, and from this small analysis we shared, the least should be 1350. So let's see, if I use 1300, will Pilesoft tell me this is wrong? So let's see 1300. Then you can see it tells me that my pile spacing fails. Why? Because what I've used is less than what is to be used. Then let's change it to 1350, which is the minimum. Then you see that this is now passing. All right, so then you can go to the pile cover for foundation. Basically, you don't want to use anything less than 50 or 75 mm cover, so I'll be using 75 as it is here. And then you go to the material selection, your grade of concrete, depending on what you want to use. You know why this is important. It tells you the unit weight of the concrete. So I'll be using let's say 25 by 30. And then the grade of your reinforcement for the links only, you could use 410. And then the steel grade as well, which is the main steel, you could use 410. And then the main diameter of your bar, Y16, and then this, yeah, I'll just keep it as it is, Y10. And then if that is done, then you can click on design data. And then if that is done, you will see your results, like your pie cap. The minimum depth of your pie cap should be 1000, and the maximum should be 1300. So basically how this is gotten is that it just takes the diameter of the pile and it multiplies it by 2, and then it adds like maybe 100 to it. Let's see, for example, if I change this, you know, we used a diameter of 450 mm, right? So if you say 450 mm multiplied by 2, that will give you 900. Then if you had like maybe 100 to it, you have 1000. So the same thing here, if you had 400 to 2D, you have 13. So let's say, for example, if I use 300 for the diameter of my pie, let's say 300, all right? And then I say design data, you see this has changed. So if you say 2 times 300, that's 600, right? 600 plus 100, that will give you 700. So this is basically how this calculates. And then the number of pile, this is due to the column load multiplied by the column diameter, all right? So if you see here, we have a column load of what? We have a column load of 3244.3, right? So if you, let me just say 20,000, right? 20,000, or let me say 30,000. 30,000. All right. So 30,000 divided by 300. So that will be your design data. So you see, in this case, you have 100 numbers. All right. Of course, this is just a testing number. You see, 100 number is incredible. That's not in any way suitable. All right. So I'll change this back to the figure that was there, and then maybe this I could use 450 as we did in the calculation. So I'm just trying to explain the data. All right, then the distance to face, I think I missed something. Yeah, I missed this. So in this place, it's asked if your pie cap is resting directly on the soil. So it could be yes or no. So if you pick no, it will automatically use a distance to face of 225. And then if you pick yes, it will use either of these. So as I was explaining from the beginning, I said your pile cap can distribute load onto your pile and also to the soil. So if it is resting on the soil as well, then it will distribute load onto the soil. But if it is not resting on the soil, then all the load goes into the pile. All right, but in cases whereby it is resting on the soil as well, then you need to know that some of the load from this pile should go to the some of this load from the pile cap should go into the pile and also into the soil. So in this case, you can click yes if the pile cap is as well sitting on the soil. All right, and then what will now be the distance between the base of the pie cap and the top of the soil? That could be maybe 150, 200, or 250. So Pilesoft will take this into consideration. All right. So I think this is what we missed. So and then if that is set, and yeah, that is all, and then you have your compression load. This is your safe working load multiplied by a factor of safety of 1.5. So depending on what your safe working load is, then this just multiplies it by 1.5, and then your penetration, we picked this to be 75 mm. So this is basically your data that you need. Then you can draft your detailed drawing with this. So thanks for watching till the end. If you have any question, you can put it in the comment section below, and if you need the software, I'll put my details in the if you need the Excel sheet, I'll put my details in the description of the video so that you can contact me and get it. Thanks for watching.